So in today's lesson, we'll be going through rules of differentiation, and regarding rules of differentiation, there'll be two rules we'll be using continuously. The first one is the power rule. Suppose you're given y is equals to x to the power of n. The power rule says the derivative of y in terms of x is equals to, you drop the exponent in, and you keep the base, and then you subtract 1 from the exponent, and that will be the power rule. The second rule is the constant rule that says, suppose you're given y is equals to 10, where 10 is a constant. The derivative of y dy dx of 10 will give you 0, meaning that the derivative of any constant number will always be 0. And then third, this is a law of exponents of the rule of differentiation. So we'll be using the law of exponent that says, if you're given that x is equals to the power of -1, this will be equals to 1 over x. And another example of this will be, if you're given a fraction of 1 over x squared, this can also be written as x to the power of -2. So we'll be using a lot of this rule. And also fourthly, we'll be using as reference when you're given a square root, for example, square root of x. What we need to know is that on the inside, if the exponent is not written, it's always 1, and then on the outside, if it's not written, it's 2. And this can also be converted as x, and then what's on the inside goes at the top, and what's on the outside goes at the bottom. And for example, if we're given a cubed and an x to the 4, this can be written as x inside over outside, which would be 4 over 3. So really we'll be using all these 4 continuously throughout and interchangeably. So let's consider the question that we're given. The questions will be given actually that are exam type questions. Right? We're asked to determine dy of dx of the following, writing all answers with positive exponents. And then that our final answer does not have to have any negative exponents. So we're given really that y is equals to x to the power of 10 plus 10x. So dy over dx will be, we drop the exponent 10, keep the base x, then subtract 1 from 10. If we subtract 1 from 10, we're going to get 10 minus 1, which will be 9. Then we repeat the process. The exponent of x there is 1, so we drop the exponent 1, multiply by 10, keep the base, subtract 1 from 1, we'll get 0. Therefore our answer will be 10 x to the power of 9. 1 times 10 will be 10, and x to the power of 0 will be 1, and 10 times 1 will be 10. That will be our answer for the first question. And we also have positive exponents, no negative exponents, which is great. So we can move on to the next question. In the next question, we're given x plus 1 over x squared. So in the first example, it was really a simple equation. There was no fractions, there was no brackets, there was no surds, and y was the subject of the formula. So just a quick recap of the things that you need to really look out for, or your checklist when you're applying rules of differentiation, is that really you always have to eliminate the following. First, you have to eliminate brackets, and this is off in no order, so I shouldn't really include the numbers because this might be confusing. It's on random order. Brackets, you have to eliminate any fractions, meaning that your variables need to always be not as a denominator but as a numerator. For example, if you have 1 over x, this needs to be changed to be x to the power of -1. You have to eliminate fractions, you have to eliminate surds. Surds, for example, the square root of x has to be written as x to the power of half. And finally, if you're deriving in terms of y dy, y needs to be subject, needs to be the subject of the formula. So really, so these are like the checklists or guiding principles when you're dealing with rules of differentiation. So in this instance, you can see that we have to eliminate brackets because we have brackets. So we're going to go about it and try to eliminate these brackets. And how do we eliminate brackets? Expand this brackets and open two identical brackets. And what you're going to do, you're going to follow them out. Should be x and x. Should be x squared. And it will be x and 1 over x, which should be x over x, and 1 over x and x should be x over x, and 1 over x times 1 over x, it will be 1 over x squared. This can be written as y is equal to x squared. 1 over x and 1 over x will give us 1. 1 over x and 1 over x will give us 1. So 1 plus 1 will give us 2. It's 1 over x squared. So we have to change this to become non-fraction. But we have to bring it to the top to do the x to the power of -2. So now that this equation has no fractions, has no surds, let's write it here as x squared plus 2 is x minus 2. So therefore dy or dx will be, we drop the exponent of x, which will be 2. X subtract 1 from the 2, it will be 1. And the derivative of a constant is 0. Drop the exponent of -2. The base of 2, subtract 1 from the exponent, -3. So we have, this will be 2x minus 2, and we have to eliminate any negative exponents. We have to be left with positive, so we can just drop this x to the bottom so that it's positive x cubed, and that will be the answer for question 2. So let's move on to question 3. See how we can answer question 3. So question 3 really has a combination. It has a combination of surds and a combination of eliminating a bracket. So we have y is equal to 4 times cube root of x plus the x cubed squared. So we have to eliminate the surd. We have to eliminate the fraction, the other brackets. So we have y is equal to 4x. The exponent of x is 1, so it's going to be inside, which is 1, over outside, which is 3, plus the 2. We will really multiply the exponent of 1 and the exponent of 3, which will be 3 to the power of 2 x. 3 to the power of 3 times 2 will be 6. So now that this looks linear, we can find dy dx, which will be, drop the exponent. We can write 4, and then we drop the exponent 1 over 3. Then it will be 1 over 3. So in the exponent, you're going to say 1 over 3 minus 1, which will give us -2 over 3. So we write -2 over 3. And then we know that we drop the exponent of 3 to the power of 2 is 9. So we drop the exponent of 6. And we keep the base of x. And then 6 minus 1. That should give us 6 minus 1 will be 5. And then what we have? Here we have 4 over 3. Then remember, the exponent needs to be positive, so we need to bring this to the bottom. It will be x. And this is the 2 is inside, and the 3 is outside. So we know that the outside will be 3, and the inside will be 2. Plus, then we're going to say 9 times 6, which will give us 50. 4x to the power of 5. And that will be our final answer with all positive exponents. So we move on to the next question. So in this question, it's the same question, you're finding dy dx, but we would have covered that question over there. We did that previously, so let's move on to something else, which will be question where we're given y is equals to 5 plus root of x over x cubed. So you see how we have a fraction here. So the easiest thing to do when you have such a fraction is to really split the top and the bottom. And this will be a life-saving trick. So you have 5 over x cubed plus root of x over x cubed. So we have fractions and a surd. So what you could do here, we can say 5, bring the x cubed to the top, it will be negative cubed. Plus, at the top we have x 1 over 2, and we have x cubed at the bottom. So we can rewrite this as y is equals to 5x negative cubed plus laws of exponents. It will be 1 over 2 minus 3, because exponents at the same base are dividing, so we keep the base and subtract the exponents. We have y is equals to 5x to the minus cubed plus the base of x to the power of, so we're going to say 0.5 minus 3, then we're going to get negative 5 over 2. Then we can find dy over dx, which will be 5 times drop the exponent of negative 3 times keep the base, subtract 1 from the exponent. And we do the same thing, drop the exponent, negative 5 over 2, keep the base, and we're going to subtract 1 from the exponent, which will be negative 5 over 2 minus 1, which will be negative 7 over 2. So we just need to tidy this up, and then we have negative 15. Then we bring the exponent bottom, x to the power of 4. Then we're going to have negative, what's positive and negative, give you negative 5 at the numerator. The denominator, we're going to have 2. Then we're going to have x. 7 will be inside, 2 will be outside. So 7 will be inside, and then 2 will be outside, but we won't really write the 2. And that would be the final answer for this question. And really that will be the summary of rules of differentiation. And as a recap, we would have really learned how to eliminate the brackets and fractions by using the laws of exponents, then surds as well, inside of outside. And fourth, we need to touch on making y the subject of the formula. So let's consider the next exercise where we're given that yx minus y is equal to 2x squared minus 2x. So you can see that this equation has no y as subject, but remember we're finding dy over dx. We're deriving y in terms of x, so we have to find y. But we can take out a common factor of y on the left hand side, will be x. We're left with x minus 1. Take out a common factor of 2x, we'll be left with 2 with x minus 1. Can divide both sides by x minus 1, x minus 1. And you can see that now our equation is y is equal to 2 to the x, and we can find the derivative of this, di over dx will be the exponent of x is 1, so it will be 2 by 1, x 1 minus 1. And this is, remember, equals to 2x to the power of 0, which is 2 times 1, which is, in a sense, 2. And then we would have covered all aspects of deriving. So in an exam, there shouldn't be a question that you aren't able to answer, because you would have covered all aspects of it.